Dr. Pia Jones Petrak.
Do you know all the particles? Well, we don't. Even 50 years after having worked out a brilliant theory that's helped us uncover a lot of particles, there are still plenty that we do not understand. But understanding them is key to unraveling the full theory. And who's not to say that this fundamental research won't pave the way for more technologies like those presented here today that would have never been possible without the fundamental research that came first. So we need to know what particles are there. I'm sure you've all heard of atoms before. They're made up of electrons going around that center, and that center is made up of neutrons and protons. A proton is made up of 3 quarks that are connected by those squiggly lines, the gluons. They glue the quarks together. How? It's the strong force, the force that stops the proton from falling apart. And we know the theory of the strong force fairly well already, but still, for a long time, we did not think of looking for particles that look like this one. Why? Because it's weird, so we call it an exotic particle. What makes it so exotic? In place of that 3rd quark, there's now this gluon. And the funny thing is, even though we never expected these exotic particles to exist, they've been in the theory all along. This is where theoretical physicists like myself come in handy when we have access to big, powerful computers like the one at Jefferson Lab. I simulate the theory of the strong force as to find these exotic particles. But why on earth do we need those computers to be so powerful? Think back to your maths classes. If you want to multiply very large numbers, you're going to need a calculator. Or you can go to the trouble of doing the calculation with pen and paper. But that's just going to take you so much longer. With the much harder problem we're facing here, we actually need computers to try out lots and lots and lots of different numbers that might solve the complicated equations of our theory. And even getting the simulation ready to run is nothing like hitting a few buttons on a calculator. If we were to try and do that with pen and paper, we still wouldn't know anything. We still wouldn't even know exotic particles that we are researching now. So, what do we do once we finally found a solution? We compare it to the GlueX experiment at Jefferson Lab. So, it's all well and good, me being a theoretical physicist, but if we cannot verify our predictions via experiments, they're useless. That being said, so are the experiments if they cannot be interpreted because there's no theory. This two-way exchange, so straightforward at Jefferson Lab, really is the decisive factor in answering the question, what particles are there?